Okay, so let's prove the law of sines. First of all, the law of sines, let's write it down so that you know what it is. It is sine of alpha over A equals sine of beta over B, which equals sine of theta. I'm going to write that again over on the left side. This also equals sine of theta over C. Now, these alpha, beta, theta, A, B, C things don't make much sense unless you have a triangle that shows you what they are. So here we have a triangle. It is just a generic triangle. It's not isosceles, it's not equilateral, it's not a right triangle. It is just a regular old triangle. It could be anything. So I'm going to go ahead and name the sides of this triangle as A, B, and C. And then I'm going to name the angles as theta, alpha, and beta. And so you can notice that beta is opposite of B and alpha is opposite of A. Kind of tried to match them up. Beta is just B with a long kind of line on the left side of it. But here we go. Let's draw a line right here so that there's a right angle right there. Okay? This is going to be helpful. Sometimes with proofs, you kind of got to know a little trick. And here the trick is draw a line from one vertice, from one angle, down to the opposite side so that it creates a right angle, so that the two lines are perpendicular. This line here is perpendicular to the one I drew. I'm just making messes over here. Okay. So they're perpendicular, they form a right angle. And I don't know anything about that line except that it is perpendicular to the side of the triangle to the C side. Okay, so let's think about trig identities here. We're going to write them out. Right, SOHCAHTOA. Okay. So, also, I'm going to call this line X. I don't know anything else about it, but I'll just say that it's X units long. Okay. So, let me try to figure out a way in which alpha, B, and X are related. That's these here. Alpha, X, and B. How those three are related. Well, if we use the trig identities, this angle here, X is opposite of the angle, and B is the hypotenuse. If you can see, since this angle is a right angle there, got X is opposite, and B is the hypotenuse. So which one of the trig identities has to do with opposite and hypotenuse? That would be sine, S-O-H, the so part of SOHCAHTOA. So if we say, we could write sine of alpha equals opposite, which is X, over hypotenuse, which is B. Now we could rewrite this in terms of X, which will be important, as we will see later, but let's just do it for now. We could multiply both sides by B and get B times sine of alpha equals X, right? Okay, let's see if we can rewrite here we go. Let's see if we can get an expression for X, beta, and A, the other triangle here, the other half of our triangle that has a right triangle there. If we look at beta, X is the opposite side, and A is the hypotenuse, because it's opposite of the right angle. So, again, that would be SOH. So we would do sine of beta equals opposite, which is x, over a, which is the hypotenuse. So if we rewrite that in terms of x, we would get a sine of beta equals x, a times sine beta. So now we have b sine of alpha equals x and a sine of beta equals x. Since they both equal x, then they have to equal each other. So we can write b times sine of alpha equals a times sine of beta. Then we could divide both sides by a and get b times sine of alpha over a equals sine of beta. And then we could divide both sides by b and get sine of alpha over a equals sine of beta over b. And there we have the law of sines. If we look back up here, sine of alpha over a equals sine of beta over b. It's exactly what we found down here. So we actually just proved the law of sines. Even though we didn't do this part over here with sine of theta and c, we picked two random sides of the triangle for a and b. So since they were randomly picked, we proved it. We proved the entire law of sines. But if you want to be sure, you could finish up this proof yourself by drawing a line down here so that this is a right angle, and doing the same proof, except doing it with theta and c and beta and b. Well, sorry, doing it with theta and c instead of alpha and a. You would use this and this. And you would do the same process that we just did, and you would be able to finish the proof.